Hey everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating work in AI. We'll be looking at a paper called Event-Enhanced Blurry Video Super-Resolution. So, the main goal here is tackling a tricky problem. How do you take a video that's both low resolution and blurry and turn it into something sharp and high resolution? Current methods often struggle with this, leaving artifacts or jittery motion. This paper introduces a neat idea, using event signals to provide extra information, specifically the motion and high-frequency details that are often lost in blurry footage. They propose a new network, Ev-DeblurVSR, designed to effectively fuse these event signals with the video frames. Okay, so let's look at Figure 1 here. It really shows the difference this approach makes. You see the original blurry, low-res input image. It's a car's license plate, pretty hard to read. Then you have the event data shown in, capturing that motion information. Compare the results. The cascade strategy and the standard Blurry Video Super-Resolution method are better than the input, sure, but still quite blurry. But look at result from this paper's method. It's much sharper, way closer to the actual ground truth shown in results. You can actually read the license plate clearly. It really highlights how using those events helps restore the fine details. So Figure 1 showed us the impressive result of using events. Now Figure 2 here gives us a clearer picture of how they actually process these event signals. They make a key distinction, splitting the events into two types based on timing. You see along the timeline there are intra-frame events, which happen during the short exposure time of a single blurry frame. These are used specifically to help deblur that frame. Then you have inter-frame events, captured between frames, which are really important for aligning the frames temporally and ensuring smooth motion. Okay, so building on that distinction between intra and interframe events, Figure 3 here shows us the actual network architecture, Ev-DeblurVSR, and how it puts these pieces together. You can see the inputs on the left. The blurry low-res frames, the intra-frame event voxels, and the interframe event voxels. The intraframe events go with the blurry features into this reciprocal feature deblurring module, or RFD, to get sharper features. Then those sharper features, along with the interframe events, feed into the hybrid deformable alignment module, the HDA, which handles the temporal alignment. Finally, everything goes through a pixel shuffle step for the final high-resolution reconstruction. Right, so we just saw how the network is put together. Figure 11 here really drives home the performance difference again, similar to what we saw in the first figure, but now comparing against a wider range of methods on the GoPro dataset. If you look closely at the zoomed-in parts, well, other techniques like FMA-Net, or even basic VSR++ retrained for this task, they still leave quite a bit of blur. But Ev-DeblurVSR consistently manages to bring back much finer details. Look at the text or the window structures. They're way sharper and clearer, really showing the benefit of that event fusion we talked about. So Figure 11 showed us the impressive results on the GoPro dataset, and now Figure 13 takes it a step further, showing comparisons on the NCER dataset. This is important because NCER uses real-world recordings, not just synthetically generated blurry video. Again, if you look at the zoomed-in sections, like the building windows or the text on signs, the other methods still struggle quite a bit with blur and clarity. But Ev-DeblurVSR, well, it consistently produces much sharper results, restoring those fine details even in these challenging real-world scenarios. It really shows the method works beyond just synthetic data. So seeing those strong results on real-world footage really seals the deal. The main takeaway, I think, is how smartly they used event data, splitting it to address both the blur inside each frame and the alignment between frames. It's a significant step forward for enhancing blurry video, especially when there's a lot of motion, and proves the value of fusing different sensor types. That's all for this week's AI Research Roundup. Thanks for listening. I'm your host, Alex.